Now that we've described the publisher, subscriber, and broker patterns and shown how these were used to provide the key architectural framework for the avionics mission computing system that we're using for our case study, let's take a look at some of the other patterns that we applied in order to achieve our broker implementation. So it turns out that the collaboration between the publisher and subscriber pattern and the broker pattern weren't the only patterns that we used in the context of our case study. And this is not at all unusual. As we've talked about a number of times before, patterns are rarely islands. So it's often the case that you use many more patterns, just a handful, even ones as architecturally significant as publisher, subscriber, and broker. So what I'm going to do now is I'm going to walk through some of the other patterns that we used in order to implement the broker pattern, and of course, more importantly, the implementation of the broker itself, which we used as middleware for the avionics mission computing system. These patterns are represented in this particular context as being used to implement object request brokers. But of course, it's very important to realize that the patterns do a lot more than that. If you take a look at this link at the bottom of the slides, you'll find many more examples of where these particular patterns have been applied to other things besides brokers. And if you take a look at this link here, you'll find a paper that describes how we applied these patterns in the context of an object request broker called the ACE orb, or DAO. The first pattern that we used to implement broker was a very important pattern described in the POSA 1 book, and this is called the layers pattern. Layers is an architectural pattern. You've undoubtedly come across this pattern before if you've worked with things like protocol stacks like TCP/IP or the OSI reference model, operating systems, virtual machines, platforms for mobile computing like Android, platforms for doing write once, run anywhere computing, such as the Java platform. And this is all about taking a large, complex set of software components, objects, classes, and then organizing them into levels of abstraction called layers. And in the particular context of our object request broker, there were a number of layers that were actually defined by the specification. So we have, of course, the operating system layer, and that also encompassed the underlying network protocols. We had something called the orb core, which was primarily responsible for things relating to concurrency control, synchronization, message passing, memory management, request demultiplexing, event demultiplexing, connection management, all that kind of good stuff. And then on top of the orb core was another layer that was called the object adapter layer. And what this would do, it would take messages that had come in from method calls on the client side and then convert them back into method calls on remote objects that were appearing on the server side. So the point was that there was a bunch of different layers, and the layers pattern was very important to help us get a handle on how to deal with the many, many classes and many methods and many lines of code we had to implement the broker pattern. It turned out over time there was probably about 1 million lines of code. So you can imagine there's a lot of functionality to partition up into easier to digest layers of capability. And that's really what layers is all about. It's about separating concerns so you can focus on certain abstractions and not have to worry about the details of abstractions below you when you're working at a particular level. Another pattern that we applied, this was a POSA 2 pattern that I had documented back in the early 1990s when I was doing my PhD work, and I was developing the adaptive communication environment, or ACE. And what ACE was basically a set of object-oriented wrapper facades that encapsulated the low-level C function call APIs, things like the Windows Win32 API back in the day, or the Unix system call API. And it encapsulated them with nice object-oriented facades. And these wrapper facades, as I called them, help to make it possible to develop object-oriented code for network programming and systems programming and things like middleware without having to get all wrapped around the axle of these non-portable, tedious, and error-prone C-level APIs that were all the rage back in the late 80s and early 90s. So these wrapper facades really provide an object-oriented encapsulation layer on top of a myriad of otherwise non-portable C-level APIs. So you had a common C++ API, which was a lot easier to program and reason about and extend and so on than the C APIs. And that pattern appears in the POSA 2 book, and you can also read about the pattern in an earlier preprint available on my website at the link below. Some other patterns that were applied, these are gang-of-four patterns primarily, are proxies and adapters, and they are used in the context of object request brokers to allow client applications to make method calls on remote objects. And what happens here, of course, is that the client makes a method call through something called a proxy, using the proxy pattern. And the proxy is responsible for converting the method call into some lower level messaging format using whatever encoding is representative for the particular middleware it uses in the operating systems and hardware platforms and so on. And then the message is sent out in its encoded form through the broker. We'll talk more about how that works in a second. And then when the message is received on the other side, it's the responsibility of something called an object adapter to convert that message back into a method call on the appropriate method on the remote object, which is, of course, residing in the server someplace. And so the proxy is the client side that converts a method into a message, and then the adapter is the reverse side or the inverse side that takes the underlying message and converts it back into a method call with all the strongly typed parameters in the correct byte order and so on and so forth. So those are kind of classic patterns from the Gang-of-Four book that help with this transition between methods to messages back to methods again. Because we were developing object request brokers that were designed to be multi-use, we wanted them to work in many, many domains, not just avionics, mission computing, but also healthcare, also other kinds of systems like automotive systems, telecom systems, online gaming, embedded systems, you name it. We wanted our middleware to work there. We ended up developing a highly strategized middleware where we had different strategies for things like the concurrency models, the synchronization strategies, the request demultiplexing strategies, the event demultiplexing strategies, the connection management strategies, the memory allocation strategies, the transport protocol strategies. If it was something that could be varied, we strategized it. And this allowed us to have a very highly configurable infrastructure that could be tuned by people trying to develop applications to customize the middleware for their particular needs, to make it optimized for the kinds of time and space trade-offs or other kinds of functionality that they required in their domain. And of course, strategy is a good old Gang-of-Four pattern. And of course, the broker pattern with the various mechanisms disclosed was something that was documented in the POSA 1 book. We also wanted to make it possible to take these strategies and create them in a way that would be dynamically configurable. We wanted to be able to essentially script the behaviors of our strategies when the middleware booted up and or even at runtime. So as things changed as the program ran, we wanted to be able to adapt and modify its behavior under different circumstances. Because it turns out, as we'll see later in this particular set of lessons, that it's hard to have a one-size-fits-all solution for middleware that will be optimal for every use case. So rather than having to statically recompile and statically relink everything, we instead applied a pattern called the component configurator pattern, which appears in the POSA 2 book. And we used this to configure factories from the Gang-of-Four book that would generate strategies. So we were able to script and dynamically configure the contexts and the infrastructure that made up the object request broker based on user needs. And of course, the factories that were dynamically configured would then produce strategies. And that's, again, the factory method and strategy pattern from the Gang-of-Four book. Now, we were also trying to develop middleware that was going to map effectively onto multi-core and multi-processor systems of the day. And we wanted to make things so that they could run concurrently, because it turns out, of course, if you're building middleware, you often want to be able to handle many requests simultaneously from different clients. And you don't want your system to have a serialization bottleneck where everything gets routed through one thread of control. So in order to do this, we ended up using a bunch of interesting concurrency and event demultiplexing and multiplexing patterns from the POSA 2 book, namely Reactor and Half-Sync, Half-Async. And we also did some work with other patterns we'll talk about later, like leader-followers pattern, which also appears in the POSA 2 book. So these were patterns that gave us better control over the kinds of concurrent processing mechanisms that we could strategize and configure into the system and make it possible to be able to have multiple things going on simultaneously, either physically at the same time, because we had a multi-processor or multi-core system, or logically simultaneous by using some kind of time slicing operations. Because we had a bunch of threads running around in various configurations, naturally it was important to ensure that any state of objects that needed to be protected against accidental corruption would be properly synchronized. And in order to do this, we applied something that's also documented in the POSA 2 book called the monitor object pattern. And of course, anybody who's programmed in Java with concurrent Java mechanisms is undoubtedly familiar with monitor objects, because that's what comes built in to Java objects through the synchronized and wait notify mechanisms that are built into Java. With C++ and with my ACE toolkit that I had developed, we also had developed various wrapper facades for mutexes and condition variables and so on that could be combined in interesting ways in order to implement the monitor object pattern. And what monitor object does is it only allows one thread of control within an object to be active at a given point in time. And it does this by using various kinds of locking mechanisms, synchronizers like mutexes, as well as various types of mechanisms for coordinating the order in which things execute, which are known as condition variables. The last pattern I'll mention here, of course, there were many more, but this is the last one we'll talk about in this discussion, is the Acceptor Connector pattern. And we use this to decouple connection management from request processing. And this was very important because we wanted to have a way of being able to connect up our middleware from client to server or client to servers, as the case may be, in a way that didn't tightly couple the connection management logic with the event demultiplexing logic, with the protocol processing logic that was being done by different layers in the middleware. So Acceptor Connector is a very powerful pattern that makes it easy to rearrange and decouple the various elements in a connection-oriented communication infrastructure like middleware, like an object request broker, and be able to handle things in a much more decoupled way that separates concerns effectively and allows lots of opportunities for extensibility and configurability. So to wrap up this discussion about the other patterns that were used to implement broker, patterns, and of course the framework embodiments of those patterns that we had implemented in our ACE toolkit helped us tremendously overcome the limitations with the conventional or traditional ways of building avionics mission computing systems. The architectures were done, of course, using things like broker and patterns like publisher subscriber, and then the broker portion of the middleware was also implemented in accordance with these other dozen or so patterns I just walked through. And we're going to be talking about these patterns later when we start to discuss pattern sequences and pattern languages, because of course, what I just described to you are the building blocks that are put together in various orderly ways to resolve the design challenges for building middleware for avionics systems. But more importantly, they're also used to build concurrent and network software in general. And so when we go a little further in this set of lessons, we're going to see that there's many interesting relationships between a whole slew of POSA and Gang-of-Four patterns, underscoring yet again the importance of not just stopping with the Gang-of-Four book, but continue to expand your knowledge to learn about other patterns that are very helpful when you build concurrent, networked, and distributed systems.